Okay, so today we topic is new topic is graphler quadratic equations. Right. So this one is maybe new to you. Just as we know, let one say generally, just like what we last class talk is this is the general standard expression of quadratic equations, right? So we can find A, B, C here. So objective here is we want to find out what x can met this station when you input this x right in this equation and find the output is 0. So we use the multi methods. Sometimes earlier we talked about use the use the factor, and most recently we talk about use the quadratic formula methods, right? And the solutions to find out what x can make this equation become 0, right? Right now we introducing is y. So the thing is introducing when x can be anything, like any numbers. X can be any real numbers. When we pick x belongs to the area can be any from the negative infinity and positive infinity. We can pick any numbers. When they input this number, what y equals to, right? That's what it actually means. We use a function. Function means when we put the input is x and have these kinds of transform inside, and then output is y. So x here is input. Just like a computer, you input some formula and generate something, right? Just like you input a lot of different components to make a cake. It's like a flour, like cake, like water, like oil, kinds of things. You put it, mix them together, and then generate finally after baking, and you get a cake. It's like a function. So, right? So this is a function. Right now we improved. So earlier, what are we doing in these cases? We only find out is what kinds of x can make this equation become 0. Right now we want to extend it a little bit. Whenever number we input here, whenever x, what we input here, what possibly generate y? What it looks like? All right. So that's today we topic. So we need to graph in this kinds of station. We need to see whenever x play out in this any real number. This is any real number, right? Any real number. When we put it in here, what it looks like. All right. So you guys maybe a little bit confusing. Let's move. I'll give some examples to explain here. Okay. Let me use the eraser. Okay, let me use some examples. All right. Okay, let's see some examples. Say what? So let's example y equal. Sorry. X squared minus 1. All right, this one. So you guys can find out what a equals to here. A equal to 1, right? What about b? Can you guys find out b? Nobody answer me. B is equal 0, right? C equal -1, right? All right. So when we put any, we say this is a function, right? When we input is x and output is y. Similar is similar like what we earlier do, what we do graphing the linear line. Do you guys really remember graphing linear line? when we do graph in linear line, y equal mx plus b, we say when we input x and generate y, right? We also use a table. And this is m is the slope, and what b is the y-intercept, right? Say that generally we can graphing like this, and this is y-intercept is x equals 0, b y equal b, right? We got this is y-intercept, right? And the slope is m. Slope is m. Slope is m. So same thing. We use the tables. We can use the tables to graph in different dot. When y equals 0, x equal what? When x equals 0, y equal what? And use at least 2 points. We graph this linear line. So right here, all the degree is only 1. So they are, of course, shows like linear line. So today, this kind of this is not degree of 1. Excuse me. Actually, this one is degree of 2 right now. So we go to the more complicated cases, all right? So let's see, put some similar like here, try to draw a table. We use the table kinds of methods as well. Okay, so firstly, we say x equal -3, y equal 8, right? When the -2, 2 squared, and here equal 3, right? -1, here equals 0. And when 0, here is -1. And that's 1, here equal what? 0, right? When the 2 equal 3, when the 3 here equal 8. Do you notice something happening here? This looks like a middle value. They are growing 0, 3, 8. What happening here? 0, 3, 8, a middle line. Looks like a pattern here, right? So if I say here is -4, here is 15, right? So here is +4, here also 15 as well, right? It looks like here is the middle line. All right, let's graphing this one out. Let me graph this one. All right, let me graph a little bit. Let me use different colors, make it easier for everyone understanding. All right. So we needed to add y, 0, x, right? So we want to -1, -2, -3, 1, 2, 3. All right. Can you guys graphing this one? You can use the table, right? -4 and 4. We just need so much. All right, so many. Most of the time, these at least 4 or 5 or 6. All right. So I just need to say 2, 4, 6, 8, 10, and 12. Right, so -2. All right, but here -1 should be here because we have data here. So firstly, let's see here. We're beginning from here. -3, 8 is about here, right? -3 and +8. 2, 3, 3 about here. 2, -2, 3. And 1 is equal 0. Exactly right here, right? So here, that. The third one is right. 0, -1. 0, -1 is right here. And 1 also got 0. And 2 got 3 is right. I'm sorry, 2, 3 got here. This one is not correct. Yep. All right, well, the 3 is got 8. Right, 3 got 8. 3, 8. It's 2, 3, right? Here is 1, 0. Here is -1, 0. All right, let's link them together. Link them together. All right, so you can see actually this one with a curve. It's not linear line anymore, right? What this looks like? Anyone can give me answer? What's it looks like? Like an open cup. The cup open upside, right? The cup is mouth is open upside. And this is one first, this mouth is open up. All right, the second one is, looks like this line, the middle line here, like a symmetric line, right? Because what? Because you can see this is any given level, just like what we earlier said, it's 3, 8, and 3, 8, and negative 3, 8. And the distance between from this point to the symmetric line, both is 8, is 3, right? This is 3, this is 3, right? And you can see if you do this one, this one here is 2. So here is also distance between here is 2 and here is 2. And the distance here is 1, here is 1, right? And the height is the same. You can see here, the height is the same, right? So this line looks like a symmetric line, called symmetric. The mouth here firstly was mouth is up, all right? I need to mark here difference first. Second one we say symmetric line, symmetric axle. This one makes x equal negative b over 2a. All right, remember this one. All right. So the third one, we say this symmetric line is equal negative b over 2a. All right, what's the b here? B is equal 0, a is equal 1, so x equals 0. So this symmetric line is x equals 0. So when you graph the linear x equals 0, it's exactly this line, right? You guys, when your x equals 0 is this line, the pink line, what I'm drawing now, right? Yes. Symmetric line. So firstly, open up. The third one, you can see this looks like a bottom dot. The bottom dot right here. The bottom dot. The bottom dot is right here, right? When the mouth open up, this is the minimum value. From the y, see, you can see this is the minimum value. So we give a name called vertex. Vertex, just similar like a called point, right? Point or peak. Here is a bottom. So vertex. This vertex is what? What's the dot here? It's 0 and 1, right? Right now with 0, negative 1. 0, negative 1, right? 0, negative 1, 0, negative 1.
What?
So this is bottom. So
yeah.
all this y value, all this y value is.
I'm taking my math class.
I understand. Anyone know you do math class now? Okay, so you can see this is the vertex. Actually, all the y value, you can see all y value is greater, is upper this part. There's no y value under this. So it means y, you can see the y actually greater or equal negative 1, right? The minimum value is negative 1. You can see from our initial expression from here, you can see x squared, this number is always, any real number x squared always greater or equal 0, right? So both sides minus 1, so it means this expression minimum value is negative 1, right? Same here, the vertex actually just expression here. So minimum value is negative 1, negative 1. Okay, so this is the third one we need to keep in mind. First is the mouth, second is find the symmetric, the third one find the vertex. The fourth one you can see when this one became 0, when this equation became 0. When this equation became 0. So it's big 0, you can go back to this one is changing into a quadratic equation, right? So you can got x equal positive 1 or negative 1 quickly. Where's the x positive 1 and negative 1? Actually, this 2 dot. What's this 2 dot means? This 2 dot means x, this parabola parabola curves intercept with x-axis, right? It's called x-interception. X-interception. That's what we talking about. Fourth, x-interception. X-intercept or interception, most of the time say intercept, is the quadratic formula solution. So it means we make this quadratic equation when they became 0. Actually, it's the solution of these two data, right? So we go back to see earlier we say the quadratic formulation, say negative b over 2a plus minus. So x equal negative b over 2a actually is the symmetric formula plus the discriminant is the distance of these two. Is the difference between these two, right? I didn't choose good color. All right, let me see. The distance of these two. The distance of these two. This is the discriminant distance. All right. So this is x-intercept. What about y-intercept? We often say x-intercept. What about y-intercept? Y-intercept is means parabola curves. Is parabola when they intercept with y. So actually vertex this one right now in this example, so exactly the y-intercept. So y-intercept means when x equals 0, what's the y value? So when x is 0 into this initial quadratic formula equation, when x input 0, y equal -1. So this vertex is also called y-intercept right now in this case. Right, it's also called y-intercept. So, super busy here, huh? Super busy in this crowd. Let me give another example. I will explain this all of them one more time so you guys can well understanding, all right? So basically, the first 5 things. One is the mouth up. Second, you need to find the symmetric axis and also find their vertex. And they are x-intercept and y-intercept, all right? So when you do graph this out, you need to find these 5 basically information, just like the position of these parabola curves. So super busy in this whiteboard right now in use this example. Let's do another one so you can better understanding, all right? Let me clear this one first. Okay, so let's see another example. I know this one pretty complicated because right now super busy. Let's do another one. Say y equal all right. Okay, see this one. So in this case, we firstly use the table. You can definitely use this table quickly. Do something, all right? Okay, so let's quickly do just like we do graphing the linear line. So x say equal -3. Okay, so you guys maybe take a little bit more calculation because there so many things need to be done, right? I use a very quicker methods to do here first, all right? We learned how to complete square first. Make this quadratic formulation become complete square. All right. So we do like this. We take this out. Right. Became -2x. Right. Plus 2. We make this one became complete square. All right. So we need a +1, right? +1 means actually -2 totally, right? So we need to make up here. Make up here. Do you know make up here? Actually, we +1 here is actually we -2 totally. So we add 2 here. So totally still go back actually in the same. So after that, so this one can be rewrite into complete square, right? +4. So in these kinds of case, we can do these kinds of process, like a complete square. So we can easy to get it. So we put a -3 here, -3 here, -1 became -4 square 16, right? -16 times -2x, -32. -32 plus 4x, -28. Is it correct? Right? So you put -2 here. Here is -3, 9, -18. Here became -14, right? So -1 here became what? -2, right? -2 square became 4. 4 times -8 here became -4, right? So you can easily get it out of here. If you get 0, 0 here became -1, and -2 it became +2. So when you put a 1 here, here became 0, here became +4, right? So you can put a 2, here became 2, right? You can see here looks like when they got 0, this looks like a middle line. So when you became 3, here became -4, here became 4, here became -14. You guys can do the calculation as well by here. So looks like here developing and here developing. This is the middle line. Do you notice that one? Just like here looks like the, I'm sorry, where I goes to. Here is the middle line. And then this one, when you developing this way and developing this way, the data spread out, they are match up. So if you got a 5, here is -28, right? So it looks like this kind of similar progress. Oh, let's graphing only one graph here. All right, let me graph a little bit like this. So here is y, here's x, here's 1, 0, 2, 3, 4. We don't need too much. Okay, -1, -2, -3. All right, looks close. Actually, we need a frame paper. Actually, make this a little bit better. Actually. Okay. All right. So see this one. So let's beginning from here. When lay 1 is 4. All right. Let me see. Let me say it's 2, 4. All right. So yeah, use the different color. Let me make here is different color. All right. So 0 here is 2. And when they became -1, it became -4. -4. When the 2 became -14, oh, that's pretty much deep. Okay, -1. Let me do it like this here. All right, so it became 2, here became 2 and 2. It looks like their position is the same. Well, it became 3. 3 here, the position looks like here is like, and when they go -4, close down here. So I'm graphing together like this one. I'm not so good graphing, but just close, all right? All right, so you can see this one right now. First thing first, these parabola curves is a little bit different from what right now example. This mouth actually open down, right? Is it correct? Mouth is open down. This mouth open up, open down. How to judge if you're not graphing? All right. Right now, the mouth open up, the earlier example. And right now, this one, we say mouth open down. It's open down. What we're graphing right now, it looks like open down. All right, we teach you a methods to judge, okay? Okay, so right here, case is A equal what? A equal -2, B equal 4, right? C equal 2, right? Right now example, we say X equal here, A equal 1, B equal 0, C equal -1. this mouse is open up. At least current cases is mouse open down. So actually we base on a value. When a greater than 0, not equal, greater than 0, this mouse will be open up, all right? You can use this one to find out when graphing this parabola curves. When a greater than 0, mouse always go up. When a is less than 0, this mouse goes down. All right, that's the thing to judge. You can see if you didn't graph it, just give you a kind of quadratic formulation, equation. When a is less than 0, you can quickly judge their mouse is open up when they open or goes down. If a less than 0, the mouse will open down. When a greater than 0, will go up. All right. So when you close, you can see this one earlier. Earlier we graphing x squared minus 1. The mouse actually open up, right? Open up. When they open up, they have a minimum value. Right? Minimum. The data is the bottom. Vertex is at the bottom. When the mouse open down, this is vertex became maximum, right? This data, this y value became maximum. So it means when mouse open down, this y value, actually all the data value, y value also behind under here, right? So here the vertex value became maximum value, y. All the data, all y value is less than 4. Here is 1, 4, right? Okay, this is actually, I jump a little bit. This is talking about the third vertex. Actually, I jump talking about the symmetric exile. Symmetric exile is right here. What's the symmetric value? Data is, you can see this one, parabola is still the same as like the early one. When we're talking about here is the left and right. They are, if they just like left hand and right hand, when you fold them to overlap together, they will be match up. Same thing here. This is line, this line. This line, when you over left or right, the distance is the same. When you fold them together based on this line, they will be matched up together as well. The distance, just like here is 2, here is 2. And with the distance here and here, they are the same. When the distance from here to here and to here, their distance is the same. They can match up, just fold together, they will be fold up. So this line we call a symmetric line. I jump right now and say symmetric line, symmetric exile, symmetric exile. So this one is x equal 1, right? This one is x equal 1, x equal 1, x equal 1. All right, let's talk about here as well. So you can see these numbers. Actually, if you make these numbers, when you finish this complete square, if you make this number become 0, this x equal 1. Earlier, we also talked about the symmetric rivalry is exact match of negative b over 2a, right? B here is positive 4. A is negative 2, 2 times negative 2. So equal 1, right? You can also use this formula to find out the symmetric exile, x equal 1, to get it out of here, from here or from here. Both can get it. So we got the firstly mouse open down, and the vertex is actually located exactly on the symmetric exile, and symmetric exile is equals to negative b over 2a, and vertex here, when the mouse goes down, vertex became the maximum. When the vertex mouth is open up, the vertex actually became the minimum value, right? We talk about 1, 2, and 3. And the fourth one, we want to talk about x-interception. X-interception here is make this quadratic equation became 0, right? Became 0, so it means this part became 0, find the solution of here. So we can use the quadratic formula methods, all right? So we also can get from complete square here. Okay, how you make this become 0? All right, let me erase this part first, the table part first, so we can have some spaces to do some more writing here. Okay. I don't like to erase all of them because of when still needed information in these parabola curves to explain more. Okay, so we want to talk about number 4. The x-interception. X-intercept it means y equals 0, right? So it means this part became 0. This quadratic formula became 0. It also measures these two intercepts. I know you guys, some of you guys maybe not a little bit confusing right here, but just let me know, talk it up, and we can explain a little bit more. I know, let me see. What glitching? Oh, did you guys still can hear me clearly? Oh no, your audio is clear. Can you guys hear me clearly?
Yes.
Yeah, I can.
All right, good.
Yes.
I saw some, maybe someone cannot hear me clearly. Sorry for that one. Right now it's good. Okay. All right. So why? So it means became 0. So this question will become more simplified, right? Because of this one will be go back to like we last talked quadratic equation, use the quadratic formula. We know that A is equal -2, B equal 4, C equal 2. So you can use the quadratic formula. We also can base on right now, we completed the square. Completed the square, right now this one became a 0, right? So x minus 1 square equals what? Equals this is -4 over -2 became 2, right? So x equal x equal what? X equal 1 plus minus square root 2. Is it correct? Right? So we don't know. So here we need to make sure. I mean, we can find the solution out of here. When the x-intercept became 0, right? So you can get when the solution here, when the solution here. Correct? All right. So another one, what's the y-interception? So right now we're just graphing down. When the x gets 0, we didn't graph in this one. When the x gets 0, what y equals 2? Actually, x equals 0, y equals 2. Here is called y-intercept, right? Y-intercept. This is the y-intercept. Y-intercept means x equals 0, right? So it means y equal x put 0 inside. You can see from the formula here. So x equals 0, the y equals 2. So actually means here, right? 2, you got 2. When you got 0, here got 2. Just these 2 points. Actually, right now is we're talking about here, y-intercept. Y-intercept here. So let's repeat it one more time here. One is mouse. When A is less than 0, mouse down. When A equal greater than 0, mouse is open up. And second is magic exile. This one is equal -b over 2a. And the third one called vertex. Vertex actually is the peak point. So right now when the mouse goes down, it's like a mountain. The vertex is exactly the top peak. So the peak became the maximum value. when the mouse will point up like a cup, the vertex is the bottom of the cup. So it's the minimum value. All right. The third one, the third one is the vertex. The fourth one, say x-intercept. X-intercept means these parabola curves, when they intercept with x-axis. So actually this one transfer into the quadratic formula equation. Find the two root. Because right now we're just drawing 1, 0, and -1, right? We don't know when they cross this x point. So x point actually right now here, we find out is 1 plus minus square root 2. So here is called irrational number, not rational number. So we didn't draw this exactly out. What's the point? We base on the solutions, we can get it out, right? And number 5 is the y-intercept. Y-intercept is when x equals 0, when these parabola curves intercept. So next week, I mean, maybe when next semester you will be goes to the Algebra 2, will be a little bit more extension. So this curve right now we talked about only this is linear line, and this linear x equals 0, this y equals 0. You got the x-intercept, get a y-intercept. And next one, you will be got a linear line is like this, is with some slope. What's this intercept? You will be going to find what this intercept, what's this point? What's this point, right? That will be a little bit complicated. We can talk this one a little bit later. This topic, today, we just need you guys how to draw these kinds of parabola curve, find their x-intercept, find their y-intercept, find their vertex, find their symmetric axis, and find the mouse open up and down. That's it. Okay, so that's all for today. So let me see what's today's homework code. All right. Today's homework code will be 518862. Let me put in whiteboard. Where's my whiteboard? Oh my gosh, where's my whiteboard go? All right, let me put it at the bottom corner, left bottom corner. Homework code. Did you guys see this one called homework code? All right, can you see homework code?
Where is it? Oh, wait, hang on. Okay, bye.
Copy down first, all right? All right, so that's all for today. So if you have any questions, just let me know. I mean, homework, please do as small as you can. Maybe we topic today didn't cover all the homework. A little bit extend, some of them maybe over a little bit more about today's topic. Okay, do as small as you can, all right? So let's see you next week. Everyone have a wonderful day. Bye-bye.
Bye.
Bye.
Thank you.
Bye-bye. Have a good day, everyone. Bye-bye.